the point P317 lies on the curve y equals x squared plus x plus 5. If Q is the point x comma x squared plus x plus 5, find the slope of the secant line PQ for the following values of x. So what's happening here? And I'm not going to draw anything to scale, I just want to sketch an idea. So x squared plus x plus 5, it's going to be the shape of a parabola. All right, I don't know what its intercepts are. I don't know if it actually even crosses the x-axis. It doesn't really matter. I want you to conceptually understand this. There are 2 points on this curve. And I'm really off because if I'm saying this is P317 and I'm down here in the negative, okay, forgive that. And then I have some random point Q up here, which is just x and the function itself. I'm going to run out of space to write that. Let me write it below. X squared plus x plus 5. So this point here, Q, can be anywhere on this curve. It's just dependent upon whatever x is. So what we're trying to do is get the slope of the tangent line by looking at different values of slopes of the secant line that are actually really close around point P. So we start and we get the slope of the tangent line, say through PQ here, and then we bring a point closer and we get the slope of the tangent line possibly through there. It gets closer and closer to the slope of the tangent line, which would be something like this. That's what we're trying to achieve here. Now, to do this, finding the slope between 2 points where one point is just based off of the function, it's really easier than you might expect. Slope is defined as y2 minus y1 over x2 minus x1. This right here defines a perfectly valid point. So I could call this x1, let me use x2, y2, and I'll call this point here x1, y1. So that y2 minus y1 would be x squared plus x plus 5, because all a function really does is hides y values for you. It's just a method of taking x values and determining y values. So you can plug a function in for y. That's fine. So then minus 17 all over x minus 3. Now, to find the value of this slope at 3.1, we're going to use the calculator. And so this is a perfectly valid function for the slope of the secant line. You could honestly plug this into your calculator and use it and get the correct answers, but it might be helpful to try and simplify it as much as you can. So clearly I could combine 5 and negative 17. So that would give me x squared plus x minus 12, it looks like, all over x minus 3. And the numerator looks like it could factor. So let's take a look. Let's see. Numerator, x and x, so this would be 3 and 4 would multiply to 12, and if the 4 is positive and the 3 is negative, that's great. And actually, look here. We have a factor that's shared in the numerator and denominator, so not exactly saying this is equal, but it's equal enough. It works for us. So the thing is, this is a pretty simple function that represents the slope. So if I want to find the slope at different values, so I would just take the slope and plug in 3.1, and actually it looks like I don't really need the calculator here, it's just 3.1 plus 4, which is 7.1. The slope at 3.01 would be 3.01 plus 4, which is 7.01. The slope at 2.9 would be 2.9 plus 4, which is 6.9. And the slope at 2.99 is 2.99, plus 4, which is 6.99. So you can see as x values get closer and closer to 3 from values that are larger, so from the right, the y values are approaching 7. As the x values approach 3 from the left, because we're values that are smaller here, these y values approach 7 as well. The limit from the left and the limit from the right agree with one another, and so that is the value of this function, the value of this tangent line. So, based on the above results, guess the slope of the tangent line to the curve at p equals 317, and that's going to be 7.